This is boy-girl paradox. What I'm going to do is give the answer pretty quick, show a quick proof, and then, yeah, you can stop the video after that. But if you want, then I'm going to show some more proofs, and I'll show why a certain method is wrong. And that's the method that I saw every mathematician use on YouTube. All right, so boy-girl paradox. We have a mother with two offspring. Maybe because they're the offspring, I thought about saying that when they get to be teenagers, one is a loser with no self-esteem, and they're always fighting, so the mother has to keep them separated. Or maybe I won't say that. Okay, so two offspring, one is a boy. What is the probability? Both are boys. It's either 1/2 or 1/3. I'll give the answer in 3, 2, 1 if you want to pause it. It is 1/2. If you get 1/3, it's because you're using the wrong model, and that's the model that all the mathematicians used on YouTube in the videos that I saw. All right, first I want to say I grew quite a few synapses working on this problem. This is about my fourth video on this. The learning theory is every time you learn something, you grow a synapse between a couple of neurons in your brain. So over the last several months or over the last year, every once in a while I look at this and I figure out something new or a different proof. So anyways, it looks like I'm growing a few synapses. Also, this video really teaches you to work on your soft skills of which would be teaching or explaining or educating. The hard skills would just be to figure out the problem and understand it, but the soft skills, such as communication, is to be able to teach this, and that's where the art comes in. So I grew quite a few synapses trying to figure out how to explain this clearly so that a child could understand. And I'm going to be using just elementary school math here and logic, so this is easy stuff. It's just there's a lot of it, and it took me a long time to put it together. So you could think of it as a pretty complicated jigsaw puzzle with 100 pieces or so, and yeah, I had to fit them all together for this video. At any rate, boy-girl paradox. I'm going to prove that one answer is correct, and that answer is 1/2. I'm also going to prove that the other answer is incorrect, and that's 1/3. I'm going to show 3 models. The first model I show is correct, second model is incorrect, and then the other model is correct. But anyways, I'll show those now. All right, so to build our models, we start with the flipping a coin. On your first flip, you either get a heads or a tails. On the second flip, you either get a heads or a tails. This is equivalent or analogous to having a baby. The first baby will either be boy or girl. Second one will either be boy or girl. So you can just replace the word heads with boys and tails with girls if you want. Here's all the possible combinations. When you flip these coins, you can get a head, 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 tail, tail, head, tail, tail. List them out in order right here. As you can see, since we're dealing with a double flip, or we're flipping 2 coins, 1/4 of the time you're going to get a head, head. This is a double event. If you're placing a bet on this event, you're betting on what's going to happen with 2 of these coins instead of just 1. So 1/4 of the time you're going to get 2 heads in a row. But also notice 1/2 of the time you're going to get a head, 1/2 of the time you're going to get a tail. And if you're making a bet or placing a bet on this, this is a single event. Count them up on the heads, 1, 2, 3, 4. 4 heads, 1, 2, 3, 4. 4 tails, showing that it's always 50-50, whether you get a head or a tail. Another way to look at this is you have a 1/2 probability of getting a heads if you flip. Heads or tails, 1/2 heads. And then if you get another heads, this is going to be 1/2 of 1/2. So this head right here, this head is half of this whole group. So this is 1/2 of 1/2. 1/2 times 1/2 equals 1/4. So you get 1/4 head heads. If you do 3 flips, then it goes 1/2 of 1/2 of 1/2. You just keep doubling the denominator, so it goes 1/2, 1/4, 1/8, 1/16 if you want to keep getting heads. Here I said, just imagine we're doing 10 to the 6th trials. So let's say we're doing 1,000,000 trials in this thought experiment. Coins hit the table at the same time, so there is no first or second flip. You just have 2 coins in a cup, and you dump the cup on the table, so they both hit at the same time. That way we don't have to worry about older, younger, or first or second. And so that takes care of the heads, tails. Let's do the boy-girl now. Same thing, boy-girl, if you have a birth, the first birth will be boy-girl, second birth will be boy-girl. So you have either boy-boy, boy-girl, girl-boy, girl-girl. Line them all up right here. Let's say these babies are all the same age as well, because you don't need to have older or younger. They could all come out at once with a C-section. These could be twins or triplets or whatever, or it could be a litter of puppy with just 2 puppies in the litter. Also of note, this part right here where it says boy 1 and boy 2 is the same boy. In this case, boy 2 has a brother. In this case, boy 2 has a sister in an alternate universe. So boy number 2 here, his name could be Schrodinger, because he exists in 2 places at once, depending on who comes out with him. Either he is a twin with a brother, or he is a twin with a sister. And if you want, you could say that he is the younger brother, or sorry, you could say he has an older brother, or you could say he has an older sister. It doesn't matter if they happen sequentially or simultaneously. So I just said here, he either has a brother or a sister. So it's important to understand these flow diagrams or this tree diagram as we continue to move through this. So I said here, same age, they could be a C-section or a litter of puppies. So for your families, if you're going to place your bets on this, you got 1,000,000 families, 10 to the 6 families, so 1,000,000 families. They each have 2 offspring. 1/4 of the families will be boy-boy. Then 1/4 of the families boy-girl, 1/4 girl-boy, 1/4 girl-girl. And if these all come out as twins at the same age, then you could combine family 2 and family 3 and say that you have 1/2 boy-girl families. Now, if you're going to place your bets here, 1/4 of these families will be boy-boy. And also 1/2 will be boys, 1/2 will be girls. You can count them up, 1, 2, 3, 4 boys, 1, 2, 3, 4 girls. But if you're betting on just either a boy or a girl, that is a 1/2 probability. And if you're betting on a double outcome of having a 2-boy family, that's going to be a 1/4 probability. I did a separate video on relating probability to how much you need to win on every bet to break even. You can see it if you want to. Next page. Here's the proof that 1/2 works. Let's take our 2 coins. You flip 2 coins in a row or at the same time. There's a 1/4 probability of head-head, boy-boy. And that is if you know nothing about either coin. So you got 2 coins on a table, they were just dumped out in a cup, you cover those coins up with a napkin, you pull the napkin away, you have a 1/4 probability of guessing head-head. The next situation though, we know that 1 is a head. What is the probability that both are heads? This is the boy-girl paradox. We know that the mother has 1 boy. What is the probability? Both are boys. They use the word both, and this is what's very, very confusing. This makes it look like a double event that we're betting on, but it is actually a single event. And I got proof for all this. So 1 coin is a head. What's the other one? It's either going to be heads or tails. And I said here we are asking about a single outcome, so 1/2 will be heads or boy. I said here, see the tree diagram, because we could be looking at the first or second head. And what this means is we have a head right here on the left. That could represent this head right here. So what can you get after this head? 1 coin hits the table, it's a head. The other coin could either be a head or a tail. That's 50-50. But what if this head right here is actually this head that we're looking at? This head could either be paired with a head or a tail. So you could follow this flow diagram forward or backward, and you have a 1/2 probability. So it is not 1/4, because 1/4 means we know nothing about either coin. But once we know something about a coin, it's 1/2 probability, because we're betting on a single event, and I have more proof for that. First off, there's the gambler's fallacy, and I'll mention that down here. The gambler's fallacy states that a previous event cannot affect a future event. Okay, so let's test it. Let's prove it. I put a star next to it there because we want to prove it. We'll do 10 to the 6 trials, 1,000,000 trials. The head-head family will be 1/4, as I've already shown. 1/4 of all flips. When you do these double flips, 1/4 of those will be head-head. Now, every time you get a head, record the next flip. What will the next flip be? Half the time, it'll be a head. The other half the time, it'll be a tail. Lest you believe in the gambler's fallacy, which states that a previous outcome having a head here will affect a future outcome, and that is not true. Next page. Oh, actually, sorry, that's actually my proof. That's it. Now I'm going to show some other proofs and show a method that is wrong. All right, so the first model I showed was right here. I think I wrote it, but I think I forgot to say it. So that's the 2 coins. That's the page I just showed. This is the first model right here, just following the tree diagram. Now I'm going to show model number 2 and show why it's wrong. Got our pairs lined up here. We have heads, head 1 and 2, head 3, head 4. You can see how they're lined up, head, 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 tail, tail, head, tail, tail. 1/4 of these families or these pairs will be head, head, or 1/4 of the families will be boy, boy. Now we know that since one offspring is a boy, then that means we cannot have a girl, girl option. So we eliminate tails, tails right there, no girl, girl. Now we go from 1/4 probability of head, head to 1/3 probability of head, head. So it goes head, 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 tail, and tail, head. Nothing magical. We just go from 1/4 to 1/3 because we just eliminated our sample right there. So in other words, if you have 4 cards on a table and they're labeled as head, 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 tail, tail, head, and tail, tail, you have 4 cards, you have a 1 out of 4 probability of picking the head, head card. But now we've cleaned up all of the tail, tail cards off the table. Now you have a 1 out of 3 probability of picking a head, head card. And that is all this model is good for. It just tells you the probability of picking a boy-boy family. And that's why this is a wrong model, but I'll keep going. I just thought of that scene from The Princess Bride. You truly have a dizzying intellect. Wait till I get going. So anyway, that's what I'm doing here. I'll keep going. Okay, so continuing with the wrong model, boy, 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 girl, girl, boy. 1/3 is a boy, boy family. Okay, so this is the wrong model, but what we need to do is modify this model to what I'll call model number 3. Because now we know that that mother is with a son. The mother has one son. Maybe we see them in public. We see mom in public with her son. She is either going to be with boy 1, boy 2, boy 3, or boy 4. One mom will be with boy 1 and 2. The other moms will be with boy 3 or boy 4 because we have 3 families. Okay, so now we have to decide boy 1, boy 2, boy 3, boy 4. Will they have a brother or a sister? You can just look up here. Boy 1 will be paired with a boy, boy 2 paired with a boy, and I'll show that on the next page. Okay, so boy 1 has a brother, boy 2 has a brother, boy 3 has a sister, boy 4 has a sister. Even if you eliminate the girl-girl group from the study, there will still be a 1/2 probability of a boy with every birth. And you will have a 1/2 probability every boy will have a brother. So here's your boys right here, 1/2 probability of having a brother, 1/2 probability of having a sister, because there are 2 brothers and 2 sisters. So model 2 is wrong, but modify it to model 3 and you'll get the right answer. I'll keep going. Why does model number 2 not predict the gender of the other person? And that is because it just tells you that if you eliminate the girl-girl category, then you will have a 1/3 probability of choosing a boy-boy family. So they're like cards on a table laying face down. Instead of having 4 cards on a table, now you only have 3 cards on a table. So you have an increased probability of choosing a boy-boy family. And then I said here, but choose any boy, and 1/2 will have a brother, and 1/2 will have a sister. And thus showing that the Mendelian genetics still hold true. I believe this may be the cause of confusion. 1/3 of moms will be in a boy-boy family, but 1/2 of boys will be in a boy-boy family. And that's because we did have 1/4 of the moms that were in a boy-boy family, or 1/4 of the coin pairs were head-head. But we eliminated the girl-girl category, so it goes up from 1/4 to 1/3. And the boys, it was 2/4 of the boys that are in a boy-boy family. 2 boys have a brother, 2 boys have a sister, but that reduces to 1/2. And eliminating the girl-girl category doesn't change that. Okay, so here's the sophistry. Every mathematician I saw on YouTube said that if a mother has a boy, she only has a 1/3 probability of having another boy. Any mathematician should know better because, first off, reason number 1, we had the Mendelian genetics in high school biology. You simply draw your Punnett square, XX, XY. The mom's egg will either have an XX. I believe those are called gametes. They're haploid. They only have half the DNA. So the mom's egg will have the sex chromosome of an X. The dad's sperm, his gamete, will either carry an X or a Y sex chromosome. If an X sperm fertilizes an X egg, you get XX. So therefore you get a girl. If it's a Y sperm that fertilizes the X egg, you get a boy. Thus, you have a 1/2 probability of girl, 1/2 probability of boy. There is a very slight variation in this, or a couple of nuances. Extremely rarely, you could have more than one sex chromosome, so you can get ambiguous gender. And also, one gender is slightly more commonly born than the other, but it's an extremely narrow margin. And there's a theory on that, that one gender can have a slight increase in a chromosomal abnormality that could lead to the pregnancy not being carried to full term. So that means it could either lead to a silent or a known miscarriage. But that is minutia. Pedantry isn't always bad because it really forces us to think and speak more precisely. All right, so at any rate, I just said 1/2 boy, 1/2 girl from the Punnett square. Any mathematician's going to learn that in high school. They're going to have it redundantly taught to them in Bio 101 in college. So yeah, everybody learns that twice if you go to college, and you learn it once if you go to high school. Next up, as you can see from the Punnett square, it is the father that determines the gender of the offspring. The father doesn't consciously determine it, but it's the father's gamete that determines it, because that sperm cell that carries either an X or a Y sex chromosome, that sperm cell will have no idea what the gender was of the previous baby that occupied that uterus. Next up, there is the gambler's fallacy that every mathematician will learn, just basic statistics that just shows, or that tells, that a previous outcome cannot affect a future outcome. And just for fun, affect is an action, so it's a verb, and effect is a noun. Thus, if you kick someone, then you affect them, but the effect will be they get hurt or they get their feelings hurt. It is strange that someone like myself that just dabbles in math for fun could solve this, or could solve what no mathematician on YouTube could solve, at least of all the videos I saw. So this shows that I either have some sort of exceptional ability, like the biologist in Big Bang Theory that wins a Nobel Prize in physics, because apparently there's no difference between biology and physics, or all the math videos that showed up on my homepage were just trolling. I'd like to think it was the first reason and not the second.